Dear all, welcome to Civil Services with ZAKI, and as you know, today we are going to discuss about the deepest earthquake ever detected. This video. So, as you know, this is our last video. As you know, your exam is very near, about the 28th May 2023. So it is the last video of this series, and as you know, this series video is related to the geography. And as you know, these videos are very significant because, as you know, in previous year about 22 questions directly from our previous video series. So you also watch some our previous video which will be also beneficial for you. And as you know, now you ready to take test. So check your strength in civil services prelims 2023. So for a free test, you can also download my app, this app, and you find various free tests for specific for the 2023 PT. So that's why this is very significant video for you and all your colleagues who are basically appearing in 2023. So we move forward and see what are the today's subtopic, and see here. Number one, about the Bonin earthquake. So basically it is the deepest earthquake ever recorded in the human history, and as you know, it is the near Japan, Bonin Island. Another is the Plutonic earthquake. So basically the deep within the earth, earthquake deep within the earth are called basically Plutonic earthquake. So we also discuss about the Plutonic earthquake, and also changing minerals. So basically why this type of the deep earthquake happen, because due to the changing structure or rearrangement of the mineral. So we also analyze what type of these minerals in the mantle, core, and the crust and the lower mantle. Another is puzzles for the geologist. So basically till today there is no any such type of the earthquake basically occur in the lower mantle. So lower mantle, as you know, the about lower mantle situated about 400 kilometer to 2900 kilometer below the our surface. So that's why it is also a puzzles for the geoscientists. So why this type of the Bonin earthquake happen or occur. Another is going deeper. So basically why this deeper earthquake happen or occur. So we also analyze the possible causes. Still it is the preliminary stage to reach the one conclusion, but some of the expectations about why this type of earthquake occurred in this such type of the ultra deep origin. And another is rare earthquake. So this is a rare earthquake. It's not happen in the century or 500 years or else, and also it is one of the most deepest earthquake recorded in the human history. And as you know, these videos are very significant for you and your colleagues for basically 2023 prelims. Prelims exam. So we also discuss about the mega question for the UPSC-CSE 2003, and as you know, it is the 5 most probable question. So now you also go to our app and download this app and take this type of the test 1, 2, 3, 4 and 5, and various tests, various free tests you can find in our app. So let's we move forward and see what is the context. So context. So the context scientists have detected. So scientists have detected the deepest earthquake ever. Deepest earthquake ever. So it is the staggering about the 467 miles, or you can call it 751 kilometer below the earth's surface. So that depths put the quake in the lower mantle, as we tell you earlier about. It is the situated near the lower mantle. So where seismology expected the earthquake to be impossible. So why the lower level or deep earthquake are impossible? Because under the extreme pressure, rock are more likely bend and deform. So as you know, see, due to the pressure, they bend. They don't break. So they are then they are break to the sudden release of energy. So what is the earthquake? As you know, we discussed several times in our class, and if you are our student, then you also know about what is the earthquake. So earthquake is the sudden release of energy which releases the seismic waves. So sudden release of energy, it means the rock breakdown, break, and that's why it is one of the most significant thing. Most of the earthquake are shallow earthquake and don't occur in the deep in the mantle or the upper mantle. So let's we go to the forward and see about Bonin earthquake. So as you know, the earthquake first reported in the June in the Journal of the Geophysical Research later was a, a minor aftershock about the 7.9 magnitude earthquake shock in the Bonin Island. So it is the aftershock, and it is very minute earthquake. So basically, researcher. Basically, it is recorded by the researcher led by the University of Arizona seismologist Eric Kasser. So basically, it is detected by the Eric Kasser quake using the Japan's high net area seismic station. So it is the one of the most technologically advanced array to detect this earthquake. So it is called high net area of the seismic stations, and and the array is the most powerful system for the detecting earthquake in the current use. So it is the world most advanced array to detect the earthquake. So as you know, vast majority of the earthquake are shallow and originating within the earth crust and upper mantle. So within the 100 kilometer, as you know, the uppermost part of the upper mantle and the crust combinedly called as the lithosphere. So lithosphere, basically 100 kilometer, it is called lithosphere. So it is also known as the lithosphere. So vast of the majority of the earthquake basically occur in the either the crust or uppermost part of the mantle. So let's we move forward and see the Bonin Island. So this is the Bonin Island, and this is the Bonin Trench, and this is the you see here Japan Trench. So basically these if you see the area of the Bonin Island is a subduction zone. So these area, see, these area are subduction zone, and it is the larger part of the ring of fire areas or ring of fire. So what is the ring of fire and earthquake and all that, then you watch my previous video, a specific video on the Pacific ring of fire, this video. So you can also watch this video. So as you know our channel provide you various kinds of the video on geography, ecology, environment, and science and tech. About more than 300 video you can find in our channel. So So let's we move forward. So this is Bonin Island. So let's we move forward and see plutonic earthquake. So what is a plutonic earthquake? Deeper in the crust and the upper mantle, the rock are hotter and under higher pressure, so which makes them less prone to break. So, but this depth earthquake can happen when high pressure push fluid-filled pores in the rocks. So, some rock you can imagine some rock are may hard and some rock may be more fluid, and some enter into the pore, and then finally these pore break, and finally it means they can a possible explanation earthquake happen in this area. So under these conditions rock also prone to brittle breakage. Also see here, these kind of dynamics can explain the earthquake down as 249 miles or 400 kilometers, which are still under the upper mantle. So if you go to the 400 kilometer is still in the upper mantle. So earthquake below the 300 kilometer. So if you find earthquake below the 300 kilometer, known as plutonic earthquake. So what is the plutonic earthquake? Earthquake below the 300 surface of the earth is called plutonic earthquake. So let's we move forward and see another thing, changing mineral. So basically these plutonic earthquake occur due to the changing arrangement in the minerals. So if we find the problem within the earthquake deeper than around the 400 kilometer has to do with the way the mineral behave under the pressure. So how these minerals behave under the pressure? For example, you can see the graphite and diamond. So graphite and diamond are the same, but their atomic arrangement are different. So that's why the graphite is the soft substances or soft minerals, whereas the diamond is the hardest substances. So due to the different conditions, different pressure conditions. So much of the planet's mantle made up of the mineral called olivine. So if we see the much of the mantle basically made by the olivine, which is shiny and green. So basically if you see the olivine minerals, it is a shiny and green like this, you see this type of, it is shiny and green, and it's also used as semi-precious metals, semi-precious gems. So these semi-precious gems, basically it is a variety of the olivine, it's called predot. So let's we move forward and see around so if you go below the 400 kilometer, the pressure caused olivine to rearrange into the different structure. So it's converted into the bluish minerals, it is called Woodslight. So Woodslight is the bluish configuration, and another, if you go to the another 100 kilometer below, these Woodslight rearrange again as ringwoodite. So it means you can go further deep. So first you can find olivine, then after 400 kilometer, below the 400 kilometer, these olivine rearrange at the woodslight, and finally these woodslights are go into further 100 kilometer deeper, they also change into the ringwoodite. So finally these ringwoodite go into the deeper places, and finally these ringwoodite go to the deeper places and split into two minerals. These are called bridgmanite and another is periclase. So periclase and bridgmanite, further they parts of these ring woodite. So basically these minerals have different type of the nature, basically the pressure, work pressure and conditions. So it means these are the some of the melted, but some minerals don't behave as usual. It means some minerals are hard, some minerals are soft. That's why the differences between maybe create such type of the earthquake below the 400 or below the 300 kilometer. It means the plutonic earthquake. So let's so puzzles for the geologist. So geoscience can probe, as you know, the far in the earth directly, but they can use lab equipment to recreate the extreme pressure to create these changes to the surface. So they can use this type of the pressure in the lab conditions. So geologists were puzzles earthquake in the upper mantle, and basically until 1980s, basically it is the great puzzles for the geologists. So why this type of the melted rock can create earthquake. So still don't agree why the occur. So some of the scientists still don't agree. So why this type of the earthquake happen in the such type of the deepest part of the earth. So in in experiment in 1980s, geologists found that olivine mineral phases were not as neat as clean. It means olivine, it means wurtzlite or ringwoodite. So it means such type of the stage is not carried across everywhere in our earth. So in such condition, the olivine directly converted into the ringwoodite. So olivine can skip the wurtzlite phase and straight to the ringwoodite. It means right to the transitions of the olivine to the ringwoodite. Under enough pressure, the mineral could actually break instead bend. So it means if they pass from these three phases, it means they can't break. But if pass directly from olivine to ringwoodite, it means they can break, and then they create earthquake. So it is basically proved by the in 19 basically its experiment created in 1889. So let's we move forward and see going to the deeper. So basically these explanation in the 80s or 89 is the earthquake below the 400 kilometer or the plutonic earthquake, but this earthquake is the 751 kilometer below the earth. It means the deepest earthquake. It means it is not the upper mantle, it is the lower mantle. So see here, going to the deeper. So the new Bonin earthquake is deeper than the transition zones. However, the 751 kilometer down, it's originated in a spot that should quarterly in lower mantle. So basically it means these type of the depth, it means this area basically the lower mantle. So if you see, one possibility is that the boundary between the upper mantle and the lower mantle just not exactly where the seismology aspect in the Bonin region. So as you know, the all earth layer, whether it is mantle, crust, core, are not uniformly across the globe, because some places are more deeper, like the Mariana Trench, like the Japan Trench, like the some of the trench in the our Pacific Ocean. So a seismologist basically not predict exactly where the transition between the lower mantle and upper mantle in these areas. So see here, the area in the basically Bonin Island is subduction zone. Basically it is in subduction zone, and where a slab of oceanic crust diving beneath the continental crust. So what is the oceanic crust, what is the continental crust, and what is the subduction zone and etc. If you want to know more about that, then you must watch our previous video, this video. So as you know, now we provide now you can find each and every video regarding the geography and related geographical concept in our you go to the playlist and major geographical concept, and you can find each and every video regarding this topic. So basically it means the continental crust basically also it is the subduction zone, and finally the oceanic crust dive in the continental crust. So some of the continental crust also go beneath the deeper to the earth center and plunge toward the earth center and much cooler than the surrounding minerals. So basically the crust is the very much cooler than the mantle or lower mantle. So it means the mineral in that area might not warm enough to complete the phase changes this supposed to given pressure. So as we see the olivine to red sugodites to ringwoodite, so they don't follow these phases, because the earth crust is the continental crust is much colder than the surrounding lower mantle. So it means they can go to the such type of the lower side or such type of the deep, and they can create earthquake. So it is as expectation, it is not clear till, because it may be take 2 to 5 years to more research about these earthquake. So why this type of the earthquake happen in such deep, ultra deep region. So see here some of the so as you know, it is the science and technology era, and you can find each and everything. Such type of the scientific basically continuous working on the betterment of the geography and physics and all scientific things. So new a global map created by the depth of the earthquake. So see here animation in animation. So you see the global earthquake depth map. So you can find this map. So see here, this is see. So this is global map of the depth of the earthquake, and here is the Bonin Island, and you can find such type of the deepest region, such type of the. So in this map you can take the cursor in the every dot, and you can find when and where these type of the earthquake happen in the recorded past history. It is the latest data till 2018. So see here, so see here, so see here. You can also zoom out or zoom in this type of the globe. So see here, this is. So see here our India is here. See. If you go to, yeah, see here, it is our India, and you can find some of the places where earthquakes. So see here, this is our subduction zone in Nepal, and you can see Kashmir and these area. So you can find this type of the various depth in the various earthquake. Basically it is the focus of the earthquake. So you can also see here subduction zone, and see here. This is our if you see this is our Pacific Ocean. So see here, See here. So see here. So see. India, 1 minute. See. So you can find each and every earthquake depth in this map. So it is a global earthquake depth map. So as you know, we provide you the best graphics, best animation. That's why please share this video with your friends, with your colleagues, and also please, if you are new, then subscribe our channel. If you are not new, so please share this video in your groups and various places, where whether it is Facebook group, WhatsApp group, Telegram, and all that. So we move forward and see the rare earthquake. So it is a rare earthquake. It can't happen in the, so whatever the cause of the earthquake, so whatever the cause of the earthquake, to scientists investigate in the upcoming 2 or 4 or 5 years. So it's not likely to repeat often. So it is the rare basically earthquake. Only about half of the subduction zone around the world even experience such type of the deep earthquake, and the kind of the large earthquake that basically preceded this ultra deep. So this is basically ultra deep one, only occurs in every 2 to 5 years. So such type of the ultra deep or deep earthquake like the Plutonic earthquake only occur 1 or 2 in 5 years. So that's why this is very significant topic for your civil services examination. And as you know, we also provide you the mega 5 question. So as you know, we regularly try, and as you see here, it's a very intensive work for this type of the research. So please, if you want to help me, then please scan this, and whatever you want, donate please. Support please. So please support our channel. For your support, we will provide new topic and new things. So as you know, it is our last video in this topic in 2023. We also provide in upcoming 2024 video also, and also some of the short video, what is the solar flare and all that. So these are some of the upcoming video you can find in our future videos. So we move to the next mega question for the UPSC 2023. So basically it is the 5 most question. So it is basically the earthquake, shallow earthquake, and it is, and also related to the about the some of the 300-kilometer earthquake, and also so for all these questions, please go to our description box for the detailed answer and all that. So for detailed answer, you can find also in our app, this app. So you can also download this app, and if you want to help us, if you are able to help, then help. If you are not have enough such type of the money or such type of the potential, then don't worry, we also provide you such type of the video. But if you are capable and you want to continue our this type of the video, then please donate us. So thanks for watching this video. Thanks a lot. We will meet for the next series with the next video, and basically we build the short video like what is the solar flare, and each and every short video. And also you can ask any question regarding the geography, ecology, environment, in science and tech for Ask Zaki sir. so for this program. So you can also ask any question, even you can write in the comment box, and we provide you the specific video on that topic and with your name. So thanks again, thanks